Tyler, what is part A? Now, part A says the rate at which the person does work. What's that really asking me? What is the rate at which we do work? The definition of power. Power. So the first thing I would say for part A is, well, power, my formula sheet says, is work over time. I think they gave me a time, 6, but 6 what? Can I call that 360 seconds? 6 times 60? Work, well, on a stair climber, I think the work you're doing is vertical. You know what? I think the work that you're doing on a stair climber is that, mgh, because I think your speed is fairly constant. You okay with that? Which is going to be, did they give me the mass? 60. G, 9.8. Now, what's the total height that I climb in that 360 seconds? Well, it seems to me each stair is 20 centimeters, 0.2. But how many stairs do I climb in that 6 minutes? I think that's my total height. You okay with that? And apparently that's going to work out to 98 watts. I don't know. I'll let you crunch the numbers. That's not how much energy I burned, though, because you may have noticed when you exercise, what other type of energy do you give off quite substantially? Heat. That's why exercise is more bang for you. But you're not just burning the energy required to do the exercise. You're burning all the energy your body is requiring to, metabolize and everything. So B asks, what's the rate at which the person uses food energy? This wants the power, I think, that I put in. The power that I got out was 98 watts. Okay? I think 20% efficient, or 0.2 as a decimal, is going to be the smaller number, which I think is the 98 watts, divided by the bigger number, which is the power that I put in. How would I solve that? Are you telling me that it's 1 fraction equals 1 fraction? Can you take it from there? Yeah. That should get you the 490 watts of power. Okay. Yeah.
Could you do number 1?
Sure.
I'm missing something.
Probably. I don't know. Let's find out. How much work does the person do? So I said the work that the person does is going to be, they gave, you know what? I think I'm going to use, because I see a distance. Which force? Well, really, it would be the applied force. Did they tell me the applied force? But did they tell me constant speed? So what force is the applied force the same size as? Okay, so even though technically it's the applied force, I know, oh, look, I know another force the same size as the applied force, friction. So part A is going to be mu mg d, because, I don't know the normal force. Oh, but look. You okay with that part? That should get you part A, I think.
Yeah, okay.
Now, why?
Well, because it's at a
Constant speed, because what you're really saying is the other definition of work was the change in potential plus the change in kinetic. Did this object gain any height? No. Did this object gain any speed? So you know how much work was done, the net work done? 0. So where'd that energy go? Friction, must have. The person added 125 joules of energy. Friction bled away 125 joules of energy. That's the only way this object could keep going at a constant speed. Because if the energies didn't match, there'd be some extra energy left over. It's got to go somewhere. It'd probably go into the kinetic, into causing it to speed up. Is that okay? Yeah. That's a nice conceptual, wrap your brain around all the different definitions of work in one, well, I guess there's no graph. Fine, sue me. There will be a graph on your test, or 2 or 5, by the way, just letting you know. So there was a bunch of those, I think, in lesson 1, which no one's asked me anything about, so please make sure you're okay with those. Any other questions? Speaking of graphs, that's today's theme. Today is called graphing tricks. Graphing tricks. Graphing tricks. For the remainder of the year, in your homework, on a quiz or on a test, I may ask you to analyze a graph. And what I'm really going to talk about, Rob, are one of 2 possibilities. Either the slope of the graph or the area under the graph. If we have two quantities that behave in the following manner, if when y is 0, x is 0, if it goes through 0, 0, the origin, and if x gets bigger, y gets bigger, we say they are directly proportional. Or we say y varies directly as x. There is a symbol, Jake, for proportional. The symbol is a little fish. Kid you not? And so we say this, y is directly proportional to x. That's what I have right there. Or if I want to turn it into an equation, what we're saying is we just need some kind of a number to go there to make these work out evenly. As an example, force is directly proportional to acceleration. What do I put in front of the a to turn it into an equation? F equals what? Okay, if I want to make this an equation, I need that. Or, let's see, let's do another one. Momentum, you might recall from last year, is proportional to the mass of an object. If I want to make that an equation, who remembers what was momentum? Momentum was what times what? Mass times velocity. Thank you, Colin. If I wanted to make it an equation, I need a proportional constant there. That sounds very confusing, Jake. Don't let it freak you out. Really what we're saying is this. If you know you go through 0, 0, if I have no acceleration, what's my force? 0. If I have no velocity, what's my momentum? 0. If I know I go through 0, 0, then the equation will look like this, where k is called the constant of proportionality. Riley, you don't need to know that term. You can make a little note, not on test. Here's what I want you to realize. The graph of such will look like that. It'll go through 0, 0, and it'll be linear. How do I know it's linear? No exponents or weird funky stuff. No square roots, no cubes, no sines, no logs, no whatever. And the slope of this graph is k. In other words, the slope of a force versus acceleration graph would be the mass of the object. The slope of a momentum versus mass graph would be the velocity of an object. I know I put the v afterwards instead of in front because on your formula sheet it's written mv, but I can use this trick to figure out, Devin, what the slope of an object of a graph means. Not just what it is, rise over run, what's the answer, but what it means in terms of physics, Jake. Here's an example. Distance equals vt if a is 0. This is going through 0, 0, because if time is 0, how far have you traveled? Nowhere. What is the slope of this graph? What is the slope of a distance versus time graph? Why? Now, if you memorized that last year, you wasted brain power. This is what I want to show you. This is why I'm doing this lesson, Addie. Slope is what over what? Let's write that down. If I'm trying to figure out, Jordan, what the slope means, I use this, but I focus on either the units or the variables. Addie, look at the y-axis. What are the units on the y-axis? Per. What are the units on the x-axis? And now the lights go on and you would ask, what do I measure in meters per second? It must be a velocity. I can figure that out without memorizing it by just going rise over run with the units. Or if that doesn't work, I'll go rise over run with the variables, and often I can spot the equation. For example, if instead this had been I don't know what newtons over meters per second squared is, but I do know what F divided by A is. I have an equation with an F and an A in it. It's got to be the mass. That's got to be kilograms, even though I had no idea that a kilogram was also a newton per meters per second squared. I didn't know that, but I can figure it out from the variables. So trick number one, if I ask you to analyze a graph and do something with the slope, Mac, divide the units or divide the variables, and 99% of the time, you'll figure it out. You do not need to memorize all these graphs. And if you did last year, you wasted brain power. Or if you did in Science 10, you wasted brain power. Oh. I should put the punchline, because it did say, what is the slope of this graph? I can even be more specific. This graph has numbers. What's the rise? 5. What's the run? You know what? 0.5 meters per second. I can be more specific. You may have noticed in your ultimate reviews that I've been giving you, occasionally there's been a question that has a graph, a written question for you to analyze. And you may have said, how the heck did Mr. Dewick in the answer key figure out the acceleration? Or how the heck did he figure out the mass? He was probably looking at the units and figured it out that it had something to do with the slope. There was one like that, for example, on your forces ultimate review. What if y isn't 0 when x is 0? What if the graph doesn't go through 0, 0? Then we say there is a indirect proportion. You don't need to know that term because you've learned it a different way. You see, as an equation, it would look like this. Y is proportional to x plus something, and if I wanted to turn it into an equation column, instead of having the proportional symbol there, look up, look up, look up, I would say a constant goes there. Or as you called it in Math 10, Colin, look up, it's y equals mx plus b. We didn't call it that in Math 10, but slope-intercept form is really an indirect proportion. Example 2. What's the slope of this graph? First of all, as a number, what's the slope? Slope is rise over run. What's the rise? 3, not 6, right? 3. What's the run? Units. Well, it's meters per second per second. Or how would I write meters per second per second? What would be a more clever way to write that? Meters per second. What is the slope of this graph actually telling us? Acceleration. This is why also I'm big on telling you guys memorize the units. It's worth it. 0.3 meters per second squared. You might have memorized last year that the slope of a velocity versus time graph is the acceleration. Addie, that's a waste of my brain because I know rise over run. I can derive what the slope means from that. By the way, what is the y-intercept? Yes, I know it's 0, 3, but what is the y-intercept telling us here? Initial what? Yeah. Part of my rant that I do in Physics 11 is, in math, graphs don't mean anything. In physics, y-intercepts and slopes, they're not just numbers, Rob. They mean something. They tell us something useful. We didn't start out at rest. Hey, what would the area under this graph be? Well, let's draw a little like that. It's a trapezoid. Oh, no. I said we don't need to know the area of a trapezoid because we can break any trapezoid up into a triangle and a rectangle. Yeah? I'll call this area 1. I'll call that area 2. What is the area of area 1? Length times width, which is, as a number? 30, right? Plus 15. Did you actually calculate it, or were you clever enough to notice it's just half of the bottom rectangle and go 30 divided by 2? Did you do that? I thought you might have, because you were pretty quick on that, okay? You could go base times height divided by 2, but I noticed it's exactly half the size of the bottom rectangle. In your head, Jose, what's 30 plus 15? 45 what units? You ready? Here's trick number 2. If they ever ask me to tell them what an area is, in any area equation, you're always multiplying. You always are. Multiply the units together. Meters per second times second. What? Are you saying the S's cancel and the area must be I think it's actually a displacement if I was going to be technical, but yeah, you know what? Did you know that ahead of time, Devin, or did you derive it from the units? I derive it from there's a few that I've memorized because I've taught them so often, but I'm telling you, this year, there's about 80 graphs out there. Don't memorize them all. It's either, Mac, going to be the slope, divide the units, or divide the variables. Or the area, multiply the units, or failing that, multiply the variables. Put your pencil down. All right. There's a third possibility. This gets us away from lines. Now let's look at curves, which I think is on the back page, yes? In other words, turn the page over. The third possibility is that x gets bigger, y gets smaller. As x increases, y decreases. We say y varies inversely as x. I hate that term. I hate that term. We should say, if I was in charge, Jake, that y varies reciprocally to x. And the reason is, in math, you guys are learning about inverse. What's the inverse in mathematics? How do you find an inverse? You switch the x and y around in the equation, right? You don't flip it. You don't. And I taught Math 12 for about a decade, and all the time, because I also marked the provincial exams, kids would get inverse and reciprocal, because you guys have also done reciprocal transformations, right? Mixed up. I wish they wouldn't call this inverse. It's not. To me, it's reciprocally related, but I can't change that. It is called inversely related. Really, you get an equation like y equals 1 over x or y equals k over x. Power equals 1 over time is proportional to 1 over time. If I want to make that an actual equation, the constant that I need to add is work. There. The longer time that you take to do something, the less power you'll generate, the less tired you'll become. The faster you do something, the smaller time is, the more power you'll generate, the bigger power is. As a graph, they look like this. These are reciprocal graphs. They are these curves. They never quite touch the y-axis. They never quite touch the x-axis because you can't divide by 0, so you can't put a 0 in. Hey, by the way, what would the area underneath this graph be? R is resistance in ohms. I is current in amps. Oh, they said area. What was my trick for area? What did I say we could try doing with the units? Multiplying. So the first thing I might try doing is I might try going ohm amp. I don't know what that is. Oh, instead of multiplying the units, what else could I try multiplying? The variables. I times R. Some of you might remember from Science 9 what I times R is. Anybody know what I times R is? I almost always have someone who's able to pull it from the depths of their cobweb. No. Has something to do with electricity. It's voltage. Remember V equals I times R, Ohm's law. You had that? We're going to ban that triangle. That triangle is dead and buried, my friend. I refuse. I will never teach that to my grade 9s. By the way, have I sold you that being able to rewrite these in your head is a much, much more versatile way to do it? Yes? Okay. You had that? By the way, I didn't know that the area under resistance versus current graph was voltage. I don't need to memorize it. If I have my equations, I can derive it.
Nothing quite like a good old-fashioned triangle, though.
Well, I would beg to differ, and since I'm in charge of your grade. Oh, that slipped out.
It's right here.
Yeah, it is right there, too. We are going to be revisiting Ohm's law, but doing it properly, not the way you did in Science 9. Okay? So, point being here, Isaac, if you give me a graph, and you almost always you'll see in the handouts, they'll give you a graph, and then they'll ask you a weird question. Based on this graph, what's the mass of the object? And you'll be going, there's no mass anywhere on the graph. I'm telling you, it's either going to be the slope or the area. Or they'll give you they'll give you a graph based on this question. How much work? I don't see any work. Again, it's going to be the slope or the area. I'm telling you. Okay. Fourth possibility: y can vary directly as x squared. Y equals kx squared. You know what? This is the good old parabola from Math 11. In fact, a half mv squared if we graph kinetic energy versus v. There's a typo that I haven't been able to, I keep forgetting to fix. Can you cross out the squared there? V is meters per second. I was cutting and pasting and anyways. Okay. If you graphed kinetic energy versus velocity, you'd get half a parabola. Why half a parabola? I know it goes through 0, 0, because if v is 0, how much kinetic energy do you have? If v, yeah, 0, okay? Then there's a trick that you can do. It's called curve straightening. Since I know this is a parabola, if I wanted to turn this curve into a straight line, because it's easier to do math with a straight line, instead of graphing kinetic energy and v, I could graph kinetic energy and on the x-axis graph v squared. If I do that, the graph will end up being a line. Kind of like this. Except, can you all look up? There should be a squared on the m there. Because velocity squared would be meters squared per second squared. That would straighten this out. Oh, and then I said, what's the slope of this graph? Well, the units would be joules per meters squared per second squared. I don't know what that is. Oh, let's try dividing the variables, because slope says divide. The variable would be ke over v squared. Yes? Do I have an equation that has kinetic energy and v squared in it? What is the equation that has kinetic energy and v squared in it? Ke equals, if you moved the v squared to the bottom, Tyler, what would be left behind on the right-hand side? The slope of this graph is half the mass. This was a classic old provincial exam question. They would give the kids a graph of Ke versus v squared. Jake, they would put numbers on it, and then they would say to the kids, how much does the object weigh? Kids would freak. Actually, it turns out they told you the mass. It's hidden in the slope. Some kids would go rise over run, and they would say, oh, the slope is m. No, actually, the slope is half the mass. You'd have to double the slope to get the mass, but then you could do something with it. So on the provincial, tells you how old this handout is. On my tests, on your final, you're going to be asked to interpret a graph. To figure out what quantity is represented by the slope, simply divide units or variables. To figure out what quantity is represented by the area, simply multiply units or variables.
Will we be asked to interpret a graph on this test?
Yep, sort of. There is a graph that has come up several times that I've mentioned very, very frequently in one of our definitions of work. That's going to be, I guarantee, there's going to be a force versus distance graph of some type on this test. Okay? But then for the remainder of this year, probably every other test, maybe every test, many of my tests will have some kind of a graph to interpret. Homework none, song, a physics eulogy. I already played that for you. Well, your homework is not none. Your homework is a take-home quiz and work on the great big review. And I got a couple of cool videos to show you too.